Hi everyone, this video is going to look at 3F on negative indices, which I know is new to you. On the screen at the moment we can see here that in this box we have our negative index law, which we're going to use in the exercise today, and it tells us that the law is a to the power of negative m is equal to 1 over a to the power of m. Now, we could just accept that as the law, but I actually want to show you how that law is created and where it comes from. So if we look at the top here, I've put given and I've written the same expression twice, which says a to the 0 divided by a to the m. Now, there's actually two different ways that we could solve this here. So if we look at this to begin with, we know that if we divide indices that have the same base, one way that we can solve them is that we could actually subtract the two indices. So a to the 0 divided by a to the m, we could also rewrite this and say that we do a to the 0 minus a to the m. Sorry, this is the dodgy part of my screen. And 0 minus m just leaves us with negative m. So we could write that answer as a to the power of negative m. Alternatively, another way that we can solve this, and which is often my preference when dividing indices, is a to the 0 divided by a to the power of m. We could first of all rewrite this as a to the 0 over a to the m. And if we think about this now, we know that any index to the power of 0 is equal to 1. So we could rewrite the numerator where we've got a to the 0 as 1, and we could now write our denominator as a to the power of m. So what we can see here is we have started with the same equation each time, but from solving them, we've come up with two different answers here. And these answers here actually are our negative index law, which we highlighted at the start. And that tells us that a to the power of negative m is equal to 1 over a to the power of m. Conversely, we have this alternate form of the law here. And what this does is it tells us that 1 over a to the power of negative m is equal to a to the power of m. So if we have a fraction where the negative index is on the denominator or the bottom of the fraction, we can rewrite that index with a positive index and make it the numerator or the top of the fraction as well. Now, what's the whole point of us knowing this? We can use our negative index law with our other index laws to simplify different answers. And the point is that we should always give our answers with positive indices when we're solving, when we're working with indices. So a question might not tell us to do that, but we should default to do that every time. I have a variety of examples here that I would like us to go through and simplify. So each one we're going to apply the negative index law. If we start here with a, we've got 3 and then y to the negative 7. So we can leave that 3 on the numerator here, and y to the negative 7, that would then go on the denominator of our fraction as a positive index. If we look at b, I've got 3 over b to the negative 5, and again we want to write this as a positive index. This is our example where we would move it to the numerator, and so we're going to say that is 3b to the power of 5. If we scroll down to C here, we've got 3y to the negative 6 times y3. If we use our index law where we multiply things with the same base, that means we add the indices together. So it'll be 3y to the power of negative 6 plus 3. That becomes negative 3. And so then I can write my final answer here as 3 over y to the power of 3. Another way that I could solve this, if you like, is you can move that negative index to the denominator straight away. So I could write this as 3y3, because those will have positive indices, over y to the power of 6. And what I can then see here is these y's are common factors, they're like terms there. They will cancel out on the top, and down the bottom here that'll become a 3. So I could rewrite my final answer here as 3 over y to the power of 3. You can see both ways we've ended up with the same answer, so you can choose which option you prefer to solve. With D, I've got p squared q cubed divided by p to the power of 7q squared. And like before, I'm going to write this as a fraction straight away. So p squared q3 over p7 q2. And then I can worry about cancelling things out. So this cancels and leaves me with p to the power of 5. And this would cancel and leave me with q to the power of 1. When I write my answer though, I can just write Q on my numerator and then P5 as my denominator. If you like, you could apply that index law where we subtract them. So we would say that this is equal to, first of all, P2 minus 7, which would be P to the negative 5. Sorry, dodgy part of my screen. So P negative 5, and then Q3 minus 2 just gives me 1. And from there, we would then move that P to the 5 to the bottom of the fraction again. With example E, we've got 7d to the negative 3 over 10d to the negative 5. Again, there's a couple of different ways we can solve this. If we like, we could flip the indices straight away to make them positive. So this is going to give me 7d to the 5 over 10d to the 3. And then we can see here that these cancel out, leave me with d squared on my numerator and 10 on the denominator. The other way that I could do this is I know that negative 3 is bigger than negative 5, so I'm actually going to leave the negative 3 where it is, but then I'm going to then subtract away negative 5. Sorry, I sort of put that bracket in the wrong spot. So subtract away negative 5 over 10. And then we've still got 7 over 10 here, but negative 3 minus negative 5, that becomes plus 5, so this will end up being d squared. I'm going to skip f because it has no negatives, so we're just going to slide on down to g. G here, we've got a little bit more complex now because we've got some brackets in there as well. So we need to consider each separate bracket first and expand out the index that's outside the brackets, and then we'll worry about simplifying the multiplication here. So remember that an index outside the brackets applies to everything inside, and we need to multiply it by the indices inside. So this here, first of all, is going to become 2 to the power of 4, which is 16. And then p to the power of 8, which is 2 times 4. And then over here we're going to have times, and this negative 2 expands to everything in here. So it'd be 3 to the negative 2, p to the negative 4, q to the negative 2. Now I'm going to rewrite this. Everything over here will actually become the denominator of a fraction. So I'm going to put here 16 p to the power of 8 over 3 squared P4 Q2, so I've now got my positive indices, and my final step is I need to simplify this. These p's here cancel out and I'd be left with 4p on the numerator, so my final answer will be 16p to the power of 4. I'm going to simplify that 3 squared to be 9, and then it'd be q squared. Just a little reminder there to watch your writing as well. You want to make sure your numbers and your pronumerals look different, so it's clear there that my 9 and my q are different numbers and letters there. If we look over at h, it is a bit of a doozy. I actually wouldn't mind if you stop the video here for a moment and try and have a go at solving this one for yourself, because it does have a few different steps, but there's also multiple different ways that we can solve it. So pause for a moment. And then come back and we'll go through the solution. So if I'm to solve this, I would like to think of these two fractions as being separate entities to begin with, and I want to simplify them as much as I can. So if I just look at my fraction on the left for a moment, we've got this 4 times the bracket, and then we've got the squaring of the bracket. So this square is going to apply to both things inside. The 4 then would multiply through afterwards, and because there's actually no whole numbers inside the bracket, we can actually just remove that straight away, put the 4 here, and then this would be x to the negative 4, y 8, and my denominator doesn't change because there's nothing happening with this just yet, so x squared, y to the negative 3. I've then got divided by, and I need to handle this second fraction. Again, the negative 3 goes to both things, so this is going to be x to the power of negative 3, y to the power of negative 3. And then down here, the 2 moves to everything, so I'd have 3 squared x to the negative 4, y to the power of 8. Now, from here, I would like to simplify each fraction, first of all. And so, if we focus on our fraction on the left, once again, that x to the negative 4, that would move to the denominator to make it a positive index. So to start with, I'm going to have 4 on the numerator. Because the x to the 4 moves to the bottom, it's x squared plus x to the 4 there, so this is going to be x to the power of 6. And then that y to the negative 3, that's going to move to my numerator, and so it'll be y to the power of 8 plus 3, so it's going to become y to the power of 11. Still got my divided by in here, and I need to simplify this. To start with, I can just make this say 9 here, because that's 3 squared, and then I've got to deal with the x's. Again, I'd like you to think which number's bigger out of negative 3 and negative 4. Negative 3 is technically bigger, so we'll move the x to the negative 4 up to the top. So this becomes x to the negative 3 minus negative 4. So that becomes plus 4. So it will actually just have a numerator of x. And then that negative 3y, that'll move to the bottom. So we'll have y to the power of 11. What we can do now, we're trying to divide two fractions. So remember, this is when we apply keep, change, flip. So we'll keep our first fraction, we'll change the sign, and we're going to flip the second fraction here. And what we can do now, oops, I just wrote 6 here, I left the x behind. Remember, when we are multiplying fractions, then we can just merge them together and collect our like terms. So 4 and 9 are like terms. 4 times 9 gives us 36. We can do y11 times y11. That means I add the indices. That gives me y to the power of 22. And again, with the x's, I would add those indices. So x to the power of 7 then, because that's what 6 plus 1 is. Our final little question here is just a question involving numbers for us to use. And remember, then that index applies to both the numerator and the denominator in the case of it being outside the fraction. So what we've got on our numerator is we've got negative 5 to the power of negative 3. And then on our denominator, we would have 4 to the power of negative 3. Now, to make these positive indices to begin with, we could flip them. So we'd actually now have 4 cubed over negative 5 all cubed. But we do need to keep that negative with that 5 there. 4 cubed means 4 times 4, which is 16, times 4 again, which is 64. And negative 5 cubed means I do negative 5 times negative 5. That gives me positive 25. But I have to multiply that by negative 5 again, which is a negative 125. So I'm going to write 125 here, but I am just going to put the negative sign at the front of my fraction. So my final answer to this one would be 64 over 125. That's all our examples here. I hope this little video was helpful for you. You now have what you need to be able to go through exercise 3F on negative indices. So please start working on those questions there and have them done for our lesson next week, where we're going to start with 3G scientific notation. And I'll see you in class then. Bye.